So today I talk about coordinate geometry. And some useful tools. Okay, first one, finding the length of a line on a coordinate grid, which we've kind of already done before. So we got 2 points. And like we've talked about, we're going to turn it into a right triangle. Like so. Or side lengths, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So again, we use the Pythagorean theorem to determine the hypotenuse. Pythagorean theorem, a squared plus b squared equals c squared. And so we'll always be solving for c. So one of our side length is 4. The other one's 11. And we'll be solving for c. The square root both sides. So c is the square root of 137. If it's a perfect square and it comes out nice and neat, that's great. If not, okay, just leave it as the square root of 137. Okay, no need to put it into a calculator and try and round. Okay, just gonna have you're just gonna probably screw it up. So just leave it as is. Yeah, you can also use the distance formula, which is pretty much the exact same thing. We want to find the length of a segment, find the 2 points. Finding the square root of x squared, or one x value minus the other x value. Okay, squared plus the difference between your 2 y values squared, you square root that whole thing. Okay. It's the exact same thing as using the Pythagorean theorem. And you can use that if it asks you to find the distance between like some really big points. Right, so let's say we had something like this, right? We want to find the distance to draw this on a graph. Okay, that would be kind of ridiculous. Okay, it'd be a really big picture since we're dealing with big numbers. Okay, but we can just plug stuff in, okay, to the distance formula, makes it a little bit easier. Okay, difference of our x values, so we get 5 minus 2 squared plus difference of our y values. Okay, so just x2 minus x1 and y2 minus y1. Square them and take the square root. And we just kind of simplify from there. Okay, 3 squared is 9, 9 squared is 81. Add them together, you get 90. So you get square root of 90 as your distance between those 2 points. All right, other thing to talk about, finding the midpoint, which is a lot easier. Okay, so anytime you want to find the midpoint, you're just finding the average. So you add your 2 x's together, divide by 2. x1 plus x2 divided by 2. And you find the average of your y values. So add your y values together and divide by 2. All right, so we got all this. Want to find the midpoint of 27 and 3651. Again, you're finding the average of your x values, you're finding the average of your y values. So you add the x values together. 2 plus 36, divide by 2. Add your y values together. 7 plus 51, divided by 2. You get 38 over 2 and 19 and 58 over 2. So midpoint would just be 1929. Go ahead and graph this on your paper to get started. Okay, we're going to graph triangle ABC. Okay, once you've graphed that, okay, I want you to find D, which is gonna be the midpoint of AB, and then find E, which is gonna be the midpoint of BC, and label those. All right, so to find D, find the midpoints of AB. So we got 0 plus 2 over 2 and 0 plus 6 over 2, which gives us 2 over 2 and 6 over 2, which just gives us 1, 3. Going right here, pretty easy. Okay, midpoint of BC, we're calling E. 2 plus 7 for our X values over 2, and 6 plus 0 over 2. So we get 9 over 2 and 6 over 2. So we get 4.5 and 3. 1, 2, 3, 4.5. 3 right there for letter E. Okay, so as we connect those two, this is referred to as a mid-segment. Okay, it's got a couple of different characteristics. First one being that DE is parallel to AC. And also that DE is half the length of AC. Okay, so the mid segment is going to be parallel with your base as well as being half of the length. Okay, pretty easy to find the length of AC. Just 1, 2, 3, 4, 5, 6, 7. And this is 1, 2, 3 and a half. All right, so 2 things I want you to do. First off, find the perimeter of triangle ABC and triangle DBE. And then also find the area of both of those shapes. Okay, so find the perimeter of the big triangle and the little triangle, as well as the area of both. Okay. All right, so you got your perimeter, you add up all the side lengths, you get about 21.135 with the big triangle, smaller triangle. Okay, using the Pythagorean theorem or the distance formula, again, you get 10.567, okay, which is going to be half of the perimeter of the bigger triangle. Okay, then for the areas, base times height divided by 2, so height of 6, base of 7, so 42 divided by 2 gives us 21. Okay, the smaller triangle, a base of 3.5, a height of 3. So we get 10.5 divided by 2, gives us a base or an area of 5.25 units squared, okay, which is going to be 1/4 of the larger one. Okay, and that's all if we use the mid segment.